If this video is hard to understand, turn on closed captions if available. Adjust the playback speed to slow down the video. Consider watching short clips, then pause, listen, and watch again. Ask someone in your home to watch the video with you. Stop frequently and talk to your partner about what you heard and understood. Hello, my name is Melody Hawkins, and I teach 8th grade science at Vine Middle Magnet School. This is the Week 2 activity follow-up, which is available in your Week 3 activity packet. Today's follow-up activity is 8th grade science. The handout that accompanies this video can be found on the Knox County Schools website under the Student Resources tab. Printed copies are given out at meal distribution sites on Wednesdays, 10 a.m. to 12 p.m. In your Week 2 review lesson, we talked about this standard. Evaluate data collected from seismographs to create a model of Earth's interior. In the Week 2 video, I shared some information with you about the deepest man-made hole on Earth, the Kola Superdeep borehole. The team of geologists were trying to see how far they could go into Earth's interior. In 1992, they ended their journey due to very high temperature and pressure and never made it much further than 1% of the distance to the center of the Earth. But why is it that geologists care so much about Earth's interior? Well, remember last week we discussed, and this school year we have learned, that studying the Earth's interior is an important factor in understanding the processes that cause plate movement and geographical features, as well as earthquakes and volcanoes. And all of this information can keep us prepared for geologic events in the future. And because no human has ever been very far into Earth's interior, scientists have had to use other ways to study and learn more about the inside of Earth. In your Week 2 review lesson, you used evidence from seismic waves to develop a model of Earth's interior and used that model to construct conclusions about Earth's interior structure. As a follow-up to your work, you are now able to answer 3 conclusion questions. Let's quickly review some information that helped you complete the Week 2 activity. Seismic waves are used as evidence to support what we know about the Earth's interior. Seismic waves are vibrations produced by earthquakes, and they reveal clues about the structure of Earth. Seismic waves are measured by using seismographs. Seismographs measure the amplitude or energy of earthquake waves as they occur over a period of time. And seismograph data show the 2 types of seismic waves, P waves and S waves. These 2 types of waves have been key in giving us more information about the Earth's interior. We also discussed the very important characteristics of P waves and S waves. But perhaps the most important difference is in their pathways. P waves travel through both solids and liquids in Earth, but S waves only travel through solids. And this evidence is very important in our knowledge of Earth's interior structure. Using data collected from seismic waves, geologists have learned that the Earth's interior is made up of several layers with differing temperature, size, pressure, and composition. These layers are the crust, the mantle, and deep into the Earth are the outer core and the inner core. And we know these layers exist because of seismic wave data. Now, in your Week 2 packet, you completed this review activity. In this activity, there were 4 seismographs at different locations on Earth: A, B, C, and D. An earthquake occurred near location A and was measured by seismographs at the 4 different locations. In part 1, you analyzed and interpreted data from 4 seismographs, so you could match each seismic data to its seismic location. Now let's take a look at your answers. Were you able to match the seismic data with the locations? Did you notice that the first set of seismic data shows the appearance of P waves much quicker than the other sets of seismic data? What about this last set of data? Did you notice that there were no S waves? And with the Earth model on the right, did you notice the locations around Earth? Here, location C is located far on the other side of where the earthquake occurred. If you were able to notice these things, then your answers should look like this. In part 2, you use the same seismic data from part 1 to develop a model of Earth's interior that shows the path of P and S seismic waves. Did you think about the path of the P and S waves as they move through the Earth from the earthquake origin? Does every set of seismic data from part 1 show both P and S waves? If not, what could this mean about the material through which these waves are traveling? If you were able to think of these questions as you worked, your diagram should look like this. Notice that the only locations to receive P and S waves are location A, B, and D. I did not draw S waves from the earthquake to location C because no S waves will reach location C. Do you remember why not? That's right, because the outer core is liquid and S waves cannot travel through liquids. So no S waves will reach location C. This also supports why there are no S waves on seismic data 4. Now you are ready to complete part 3 from the week 2 activity by answering conclusion questions. These questions can be found in your week 3 activity packet. Answering these conclusion questions will ensure that you understand how seismic data can be used as evidence for Earth's interior. You can check your answers by going to the Knox County Schools website under the Student Resources tab, or by receiving a printed copy at meal distribution sites. Thank you again for joining me for the 8th grade science week 2 follow-up lesson on the evidence of Earth's interior. Remember, you can find these lessons and activities on the Knox County Schools website under the Student Resources tab. And you can also receive a printed copy at meal distribution sites on Wednesdays from 10 a.m. to 12 p.m. noon. Stay safe and stay healthy.